When you look at antenna technology, there are two major spaces. There are gateway antennas, what I'll dub gateway antennas, and then there are user terminal type antennas, which are very different segments of the market because the requirements are quite a bit different. But I think in general, I would say that advancements in simulation and modeling for electromagnetics has been a big player in antenna design, antenna technology fundamentals, both the feed microwave networks as well as the optics of the reflectors and optimizing performance. So I think that's one area that I've seen a lot of change over the past 15 years, improvements. And I think that's translated into sort of a deeper understanding of antennas and their performance predictability, which has been really important as we get higher in frequency. The other area I would say, probably in the past 12 years or so, has been the move to hub-based antenna. And again, here in this case, I'm speaking about gateways, where you have an enclosure built into the vertex of the antenna, large aperture antenna, we refer to as a hub. It's a big equipment room built right over the elevation axis. And this really, I think, has been a game changer from a systemic standpoint in antenna design, antenna deployment, that's been also aided by advancements in TWTA technology. So now you can move your amplifier and your transmission systems out of buildings with klystrons and narrowband systems into wideband systems that can be mounted right at the vertex of the antenna. And this was huge in KA, and it's going to be absolutely critical in V-band as we go higher in frequency. Yeah, I think, again, thinking about that user terminal versus gateway perspective, and I'm coming at it largely from a gateway angle here. I think whenever you think of multi-orbit, you immediately have to consider tracking. You have to follow the satellite because it's moving. It's moving a lot. So how do you do that? In the case of user terminals and flat panels, there's electronic beam steering and things that you can use to make that, to affect that tracking. In the case of parabolic antennas or high gain antennas, typically gateway antennas, although not exclusively, but usually, you're in parabolics, you're highly focused antennas with very narrow beams. So you immediately, you think about tracking and how do you track? And motorizing an antenna is, from a user terminal perspective, kind of pricey, when that user terminal needs to be really inexpensive. In gateways, it can be critical in terms of following the satellite accurately to maintain maximum system gain because you're throughputing, huge amounts of bandwidth over the bird. So I think really what you have to focus on is the economics of tracking the satellite. When you think of multi-orbit constellations, that really becomes, from an antenna perspective, that really becomes the first thing you think about. User terminals, when I think of flat panel technology, I think of comparatively lower frequency bands, and I think of user terminals. I think that's really where that technology will play. How it will play and exactly how it will get implemented, I think, is somewhat of an open question. Again, I'm coming at this from a gateway perspective, not an expert in user terminals, although I'm pretty familiar with the economics and typically how they're made. But I think watching the market, one of the interesting things I've observed is watching the large constellation players, and notably one of them specifically that I'm thinking of has developed their own terminal. Many of them consider it a game changer in terms of their competitive advantage. So how those get implemented and the economics around those are very interesting, and I think will be challenging. And it's interesting to watch the big guys and see how they solve that problem. Right. Yeah, and that's really the space we're pursuing is higher frequency in our business. But I think generally people go to the higher bands, certainly for Ka and most certainly for V band for the bandwidth. It's the capacity that they're after. Nobody does it because it's cheap. So challenges really revolve around when you get up to that kind of wavelength in a large aperture gateway terminal, forming the beam and forming it accurately and consistently and maintaining that beam to maintain system gain on the satellite is critical. And because the wavelength is so short, it doesn't take much to defocus an antenna or to distort its pattern and to compromise your gain. So things like how you de-ice antennas and how you focus them and the coefficient of thermal expansion of the materials that you're using. When the sun goes up, the sun goes down, causes everything to shift, can defocus your antenna. So these are things that are really important. Compounding that challenge is the bandwidth. You've got Ka, which is 2.5 gigahertz of spectrum, give or take, depending on whether or not you're operating in the military bands. You're moving to V band, and now you're in 4.5, 5 gigahertz of spectrum. So that really puts a weight on the electronics, not only in frequency, but then having to perform accurately over an enormous bandwidth. And so I think those are the areas that really make a difference. I'd say that the last thing I would point to is that in my observations so far, talking to customers, you can't really think of a V band spectrum deployment the way you think of a C band or a KU band deployment. It's not just a different link calculation and higher gain. It's a whole different network topology because the bandwidth is so much higher. So in terms of modem technologies, it really depends on what the customer is trying to accomplish, and that can ripple into the requirements on the RF side as well. Part of the market that's going to be concerned about interference the most, either receiving it or issuing it or creating it, is probably the mobile terminal or user terminal market space, where customers are installing their systems, kind of anywhere. And I think that's probably the biggest, when you think of interference and the impact on the market, that's probably the biggest area of focus. And that'll be dependent a lot on the band choice. We're seeing C-band with 5G reallocations. C-band's been sharing terrestrial microwave spectrum for decades and coordinating with it. So I guess, that's really a user terminal focus. I think that's where those issues are going to come up. And I think only time's going to tell in terms of what that impact is and how to solve those problems.